of you. Today we will start one new chapter, chapter 5. So Euclid's geometry. There are some definitions and some postulates that we have to memorize. So Euclid's definition and Euclid's postulates that is given in the textbook. You all are asked to open your textbook and underline the points and memorize it. So we will start exercise 5.1. Question number 1. Which of the following statements are true and which are false? Give reasons for your answer. So write true or false with reasons. So only one line can pass through a single point. This is true or false, and if it is true, why it is true, and if false, why this is false. That reason also to be written here. Question number 1. Only one line can pass through a single point. So we have learned before that through a single point many lines can be passing through. So here the given statement is false because through a point infinitely many lines can be drawn. So it is false, as if we take a point O on a plane of paper, if we take a point O on a plain paper, we can draw infinite number lines through the point. Take a single point as O. Through this point, a number of lines can be drawn. Number of lines can be drawn through a single point O. Infinite number of lines can be drawn. So through this point O, infinite number of lines can be drawn. Coming to the question number 2, there are an infinite number of lines which pass through two distinct points, 2 points. So through 2 points, infinite number of lines cannot be drawn. Through 2 points, only one line can be drawn. But through a single point, infinite number of lines can be drawn, but with 2 points, only one line can be drawn. So the given statement is there are an infinite number of lines, so it is false. So this is false, as 2 lines as one line can be drawn through 2 distinct points. Through 2 distinct points, one line can be drawn. Name 2 points A and B. These two are distinct points, different points. Through these 2 points, one line can be drawn, as it is shown in the figure. So as one line can be drawn through two distinct points, as shown in the figure. As shown in the figure. Now, question number 3. A terminated line can be produced indefinitely on both the sides. So, this is true or false? A terminated line can be produced indefinitely on both the sides. A terminated line, so it is true, as postulate 2 says that a terminated line can be produced indefinitely. This is postulate 2. Question number 3. So it is given a terminated line can be produced indefinitely on both the sides. So this is true, as postulates two says that a terminated line can be produced indefinitely. So it is true, according to the postulates 2. Question number 4. If two circles are equal, then their radii are equal. It is also true, because radius is that distance from center to the circle. Question number 4. Two circles are equal when their radii are equal. It is also true. This is also true, as the centers and boundaries coincides, means center and boundary will be same. So area will not be different. That is why these two circles are equal. They will occupy equal area. So here true, it is true, because two circles are equal when their radius will be equal. It is true, as the centers and the boundaries coincide. Coincide means center and boundary will be same. Question number 5. So here a statement is given: AB and PQ both are equal. AB equal to PQ. It is given, and PQ is equal to XY. It is given. Then AB equal to XY. This is our question. So we have to show that AB equal to XY when AB equal to PQ and PQ equal to XY. So this is true. This is true because AB equal to PQ and PQ equal to XY. PQ is equal to XY. PQ equal to XY. So for this PQ, we can place the value. Therefore, AB is equal to, for PQ, what can we place? Now its value is XY. XY is placed. Since PQ equal to XY, that is why the value of PQ XY is placed here. One postulates also there. If things are if things are equal to equal, then they are equal each other. So it is also true. So question number 1 completed. Going to question number 2. Give a definition for each of the following terms. Are there other terms that can be defined first? What are they and how might you define them? So here parallel lines, perpendicular lines, line segment, radius of a circle and square. So these things we have to define. So before going to define these points, we need to know some more points. That is, so here some more things we need to know. Yes, some more definitions we need to know. Are there other terms? Yes, we need to know. We need to know about a point, a ray, angle, line or line segment, quadrilateral, etc. Ray, line, angle, quadrilateral, etc. etc. So these things we need to know before defining these things. A point, ray, angle, quadrilateral, etc. Now first we are going to define parallel lines. Parallel lines. Line L and M can be parallel if they have no common point. Line L and M can be parallel. Line L and M can be said parallel. Can be said parallel if they have no common point. If they have no common point. So according to the figure, line L, this is line L, and line M, these two lines are called parallel because these two lines have no common point, means these two lines will never meet at a point. So these two lines are called parallel. That is line M parallel to M. In this way it can be written. Second part, perpendicular lines. Perpendicular lines. Perpendicular lines. Two lines can be said perpendicular if they form a right angle. Two lines L and M can be said perpendicular if they form a right angle, that is 90 degree. A right angle. It can be written as line L perpendicular to M. So line L and M, they form 90 degree. L, M. So this is 90 degree. So these two lines are called perpendicular. A line segment. A line segment. A line segment is a part of a line segment is a part of a line. A line segment is a part of a line. Which has definite length. Which has definite length. AB is a line segment. AB is a line segment. Here A, here B. AB. AB is a line segment. Radius of a circle. The distance from center to the circle is called radius, or half of diameter is also called radius. So distance from center to the circle. Radius of a circle the distance from center to the circle is called radius. In the figure, AB is a radius. So this is the circle. If it is center is A, and this is the point on the circumference of the circle, AB is a radius. Question number 5, A square. Square. If all the sides and all the angles are equal, if all the angles are 90 degree and all the sides are equal, a quadrilateral in which all the sides are equal, and each angle is 90 degree. Is called square. ABCD is a square. All the sides are equal. A, B, C, D. All the sides are equal and every angle is 90 degree. So thank you children for today this much. We'll meet you in the next video. Take care of you and thank you.